Okay, it's loans and investments, day one. We are going to be basically teaching you the same kind of stuff that we were doing, except stepping it up a big notch to be able to handle monthly payments. That's really all it is. You guys have done this. U0 equals 20,000. We had this kind of thing on your last test. And UN, or U sub n, because U sub n minus 1 times 1. And you remember me saying I always want you to put plus whatever in there? And you guys did a great job on that in the test. A few of you forgot, but it's actually not wrong if you put 1.085, for instance, on a problem. But I like to have it separated like that. Here's why. Because now we're finally to the day where we can start making, instead of annual payments, which you knew to put out here, we'd always put a minus something if we were going to make a payment. Remember that? Just only a couple of you thought that was a plus. But you don't want a loan. If this is a loan for 20,000, you don't want a loan to grow. You want it to shrink eventually down to 0, right? So if we're going to make it shrink, we got to subtract from it. So if our payment was going to be, let's say, $100, that was our old system. Would you please write down for me what was the principal, by the way? That means the amount you borrowed. So just put P equals this. What's the principal? I want you to get you used to that word because we're going to use it a lot. It's the amount you borrow or the amount you invest. If you're like a money manager and somebody comes to you, they just inherited $300,000, they might say, okay, I have $300,000 in principal. That means the money I have to invest. Okay, and if it's a loan, it's the starting amount of the loan. What was the interest rate? What was the rate here? Now, in the context of this being a recursion sequence, then there was also something called a common ratio. That's different than the rate. What was the common ratio here on this problem? And what was our payment in this problem? All right, I'm going to ask different people for those answers. Sometimes to just randomize who I'm calling on so that I don't just take hands. Hands are good because they're volunteers, they usually are right. But it's also good to just call on people randomly because it makes everybody a little more on their toes and ready. Because if you know I'm just going to call on hands, you can not do the problem even because I probably wouldn't call on you. All right, this is row 6. I count from the left. So 1, 2, 3, 4, 5, 6. And person 2. Person 2, that would be you. Would you tell me the first one? Which one did I ask for first? The principal. What was that? All right, you got the easy one. Good job. Why don't you give me another one then? The rate. This was the rate. 0.085, but if you had put 0.085 on the test, I'd have to mark it wrong. What is the actual rate? 8.5%. Notice there's always a 2 decimal point difference there. 8.5%. Okay. The last two, row 1, person 3. Well, what's left? Common ratio, and what was that? Okay. This whole thing is the common ratio. So it's 1.085. All right, that was a key difference. The common ratio versus the rate. That's one of the things you really got to make sure you understand in this unit. All right, and the last thing, row 5, person 5. Yep. All right, and just to clarify, that payment, was that $100 a month, or was that $100 a year, or $100 whenever you want to, or what was the deal? Per year. Because everything in this problem is per year. The only difference today, I'm trying to connect the old stuff to the new stuff here. The only difference is that we're making monthly payments. So we need to somehow reflect the fact that instead of 1 payment every year, we're going to make 12 payments per year, right? So then, all I have to do is put a divide by 12 right there, and that's it. Notice that's not including the 1. This is not a big divide, the whole thing by 12. It's just the 0.085. Do you see even more why I wanted you to separate those two with a plus or a minus? Because that part right there now is reflecting the fact that there's 12 payments per year. That's it. Now, one thing that complicates this then, in the chart, when you looked in the past at U sub 0, that was always the starting number. And U sub 1 would be after the first year. Guess the difference now. U sub 1 is now after the first month. And you know the common mistake people are going to make. I'm going to ask for 5 years later, and they're going to go to U sub 5. That's going to be 5 months later, right? All right. And if you really want 5 years later, you got to go to U sub 5 times 12, which would be 60, U sub 60. See what I mean? You got to look way further down the charts on these. Because again, when you put these in the calculator, you've changed it by just throwing in this thing right here. It's going to change your what you count by. And you count by months now. All right. Let's put one of these in the calculator. Everybody grab your graphing calculator if you need to borrow one. Make it fast. I'll pause for a second while we get those ready. All right. So take your calculator and put this in. This part, ideally, you would put a separate parenthesis around the whole thing to keep the 0.085 divided by 12 separate. Now, actually, it doesn't have to have that parenthesis. But again, I think it's good for you. And just like I was telling you before, it really would be good for you to put in this plus, make it 1 plus 0.085. Trust me on the extra parentheses here. The only thing that sometimes happens is people don't have an end parenthesis or something, and it messes up their formula. So just be careful. You have, in the end, 2 front parentheses and 2 end parentheses. All right. I'm going to pause for a second while you get that in the calc. Okay, so here's the typical change from what we did before to what we're doing now. I'm going to insert right here an extra parenthesis. Something didn't work right there. Insert a parenthesis. There we go. Okay, and then a 0.085 divide by 12. And then an extra end parenthesis, so 2 end parentheses. And then I'm going to say minus 100. Can anybody tell me ahead of time an issue that we might have in this problem? Just because of how it's being set up? I agree. The student said that we aren't paying enough. If you're going to only pay $100 a year, or sorry, $100 a month to pay off a $20,000 loan, that's probably not going to be enough. And how would you know that? If you look at the chart, you can tell. I'm going to pause because my calculator just died. All right, so we're back in here, and we were changing this formula when my calculator died. So I'm going to do, instead of inserting, I'm just going to write right over the top of this, parentheses, 0.085 divided by 12, end the parentheses, another end the parentheses, and then minus, let's change it to a $1,000 payment. In the real world, you don't get to pick your payment. They'll tell you at the bank, here's how much you need to pay to get it paid off in 5 years or whatever. Typical car loans, 5 years. Typical house loan is 30 years. It makes sense. You have to, it takes a lot longer to pay off a house because it's so expensive. All right, and this was a $20,000 loan. Okay, now, if you think about this, I'm going to go check my table settings because if I start at some weird place, that's not going to help. I'm going to start at 0 because that's what I did, U sub 0. If I had done this for a year thing that was going to go annually, like I started in 2015, that doesn't work so good in these problems anymore because these are monthly. You know what I mean? If I say U sub 2015, then that's going to imply that U sub 2016 is next year when it's really only next month. See what I mean? So you're going to always start these things with u sub 0. All right. And I'm going to go to my table. And my loan balance went from 20,000 to 19 to 18. That's working out pretty nice. Is it paid off yet? No. How do I figure out where it's paid off? Yeah, just keep going down here, and I'm paying $1,000 per month, remember, and these are each month. So I should, if I said it wrong before, after 12, that's 1 year. So 1 year later, it's paying off pretty quick. Now think about it. If you only borrowed 20,000 and you pay monthly payments of 1,000, that's 12,000 a year you're paying, right? So it should pay off pretty quick. All right, I'm going to keep going until I figure out where it's paid off. And this is where all the nitty-gritty like mistakes happen, right in here. We're getting close to having it paid off. And oh my gosh, so many people said, well, it was between this year and this year that it got paid off. Like they'd say it was between year 20 or month 20 and month 22. Nope, it's not. At the end of month, in this case 21, I still owed money. It was not paid off at all in year 20 or in month 21. Okay? In month 22 is when it got paid off. It wasn't between the two. So I had to mark, that was only probably 5 people, not in here even total, that said between this month and that month. You had to say it was that month, or the problems we did on the test were yearly, so in that year. It was that year it got paid off. And what does that negative mean? Real world, they owe you money now. Because you could have, of course, actually they'll be happy to do this at the bank if you're about to pay off your loan. On your very last payment, you call them up and you say, how much should I pay? Okay, and they will tell you, okay, you don't have to pay us $1,000 this time. You have to pay us like $644 or whatever. Okay, they'll tell you the exact amount to pay off. But if you just simply do pay the $1,000, they will have to mail you a check for this. All right, so this moment on the table is critical, super important, and let's talk about what we know. It took 22 months to pay off, which means 22 payments of how much? $1,000. So how much total did you pay on your loan? That is a typical question. How much total did you pay on your loan? Would you please take a moment, use your calculator and your iPad to actually write out the answer to this. How much total did you pay for this loan? Don't say 20,000 because, yeah, that's how much you borrowed, but how much did you pay? Now I'm going to pair you with somebody, and I want you to be able to compare answers with them. It's these 2 rows here, and you guys are a group of 3 in the back. It's 1, 2, 3, 4, 5 here and 3 there. That's not going to work as good. Miss P, would you move up here, please, just for this next 15 minutes or so? And then we have 2, 4, there's 6 in this row. There's something wrong with that. It's supposed to be only 5 in this row, but anyway, we'll figure that out later. 2, 4, 5. We're just going to go across the rows this way, and it's got to be a little bit diagonal. U2, 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 and then U3. Okay? All right. I want you to show them in a moment. Don't do it yet, because I know there's a lot of people not done. How much total did you pay, really? After they've given you a refund, you got to factor that in. After they've given you a refund, how much did you pay total? And here's the other question. How much of it was interest? Some of it was just paying back the money you borrowed, right? Because they gave you money in the first place. Some of that doesn't count. So if your grand total was like, $24,300, then the interest amount would be subtract off how much you really borrowed in the first place. All right, get those 2 amounts. If you understand this, that's the main thing we need to get over the next 2 days. going to pause for a second. Okay, to see how you did on this one, you should have said I made 22 payments of $1,000. Is it at 22,000? What would be wrong with that statement? You paid 22,000. Yes. Yeah, they owe you $356.40. So you subtract $356.40, grand total 21,000. Help me with the math here. 643.6. Oh, now this is important. On the test, we were kind of loosey-goosey on rounding. We didn't say exactly where to round, so be careful. If they ask you to round to the nearest dollar, then if it's a 0.6, you'd have to round this up to a 4, right? And 0.6 all alone like this just looks ridiculous. You'd never see that price, ever. They'd have a 0 on the end of it if they're going to round to the 10 cents. Okay? So you should never leave an answer like this if it's in money. But I can throw a 0 on there, and then it'd be okay if I wasn't told where to round. All right, how much of that is interest? It's really simple. You owed 20. You paid back 21,643. So the grand total is you subtract the 20,000 off, 1,643.60. That's how much the bank made in interest over the course of 22 months. Remember, this was by months, right? So the 22 was 22 months. So it's about 2 years. That's not bad. The bank made $1,600 in 2 years. That's why banks, that's how they make money, really, is by loaning money out to other people. They certainly don't make much money on interest themselves because the interest rates they get paid nowadays for investing in like bonds and whatever is almost nothing. That's why they have to make money on what's called the spread. They take money in from you. You give them, let's say, all of you guys in here probably have $1,000 in the bank, I'm guessing, just from Christmas gifts and whatever, who knows. And if we have 30 of you, there's 30,000 in the bank, right? What does the bank do? They have to pay you interest, but they pay you just pennies on your $1,000 of interest. It's just tiny interest. They, in turn, though, take that 30,000 and they loan it to somebody. Let's say they loan it to me. I'd get that 30,000 and I have to pay them back. And then eventually, when I'm all done, I've paid them back more than 30,000. And so now that's how the bank made money. They took money from you guys and loaned it to somebody else. And in the meantime, they have to keep cash in the bank because, like, if it was a real bank and I actually did that, I loaned out every dollar everybody had given me. Then what if somebody comes next week and wants their $1,000 back? You wouldn't have it, right? And if everybody decided to get all their money back at once, the banks wouldn't have it. That's why the banks actually have rules on how much you can take out per day. You probably don't even know that. And if you have a small amount of money, it probably doesn't matter to you. But if everybody decided to go back and get their money right now, they can't. They loaned it to somebody else. So that's called a run on the bank. And that has happened in past history where banks have collapsed because people have gone in and said, want my money back now. If everybody goes back at the same time and does that, they don't have it. They can't do it. So there's rules about how much money the bank has to keep in reserves and all that. So, all right, I thought I'd add that real world part to this so that you know what's happening out there in a real bank. Yes, sir. Can you show again how you got this? Yes, it was this amount. Did you get this amount? Okay, then that was just the 22 payments and then subtract how much they owe you back. And then this amount right here, I just subtract off the original loan minus 20,000. That's how I got this. All right. So that's a loan scenario. Those are much harder than the investments. The investment scenarios are more fun. Let's talk about an investment scenario. Let's actually go in here. This was a loan, so we'll skip over that one. This is the interest thing. All right. So you could do this semi-annually, quarterly, monthly, weekly, or daily. Which one did we do last time? Monthly. And how was that in our formula? I'm going to look back at the formula. How is the monthly in this formula? Right there. Divide by 12. So if they do quarterly, do you know how many payments that would be? 4. How about annually? Once. And could I put a divide by 1 here? And it wouldn't actually even change my original equation. That's what we were doing before. Before we ever told you about this, you were always doing it annually, okay? So just don't worry about all these words other than to know what they mean. Semi means twice a year, 2 payments per year. This means 4 payments per year. This means 12 payments per year. Weekly, 52 payments per year. And daily payments, you divide by 365. You could have a daily payment. I mean, that'd be a little weird. I've never seen a loan in the real world that's like that. I've never even seen a weekly either. I do see this one on my taxes on a cabin that I'm in charge of. It's not really mine personally. We own it between 3 of us. And it's a semi-annual tax payment, so I got to pay it twice a year. Quarterly, I see that on some of my bills, but it's really rare. Most of my bills are monthly. The monthly mortgage payments and those kinds of things. Yeah, almost everything's monthly. Car payments would be monthly. Weekly, never seen it. Daily, never seen it. But that's what they would be. Okay. Remember how I said this thing's called principal? That's the amount you borrow. And this is the just fancy way to write this formula that we just did. The new part is really just right here. Now, this part, look at how it has a plus and a minus. It's because it depends. If you're doing an investment, you don't want it to eventually become 0, right? That'd be a really bad investment. So you want to add an amount right here as a payment. All right? So that's the only thing that changes. That's, in fact, the only way you can tell whether you're doing a loan problem or an investment problem. If you look at the formula, that's the only thing that'd be different. So here's one, for instance, for you get U sub 0. Always start these with U sub 0. You get $10,000 when your great aunt Tilly dies, and you invest it at, let's say, the stock market on average grows at about 8%. 1 plus 0.08. Now, the only reason they don't pay you 8% every month. So if we're going to start doing something monthly, we got to put it divided by 12. We're going to do something monthly. We're going to add to the money Great Aunt Tilly gave us. Let's say you feel like, you know what, I can actually afford to save $10 a month. You're a high school kid, so you don't have tons of money. There we go. That's what you do to add a $10 a month to your investment. Would you please figure out for me how much Aunt Tilly's money would have grown to in 3 years? I'll pause for a second while you put that in. Compare it to the person I paired you with. See if you get the same thing as them. I bet you'll catch some mistakes. First thing to do is compare your y equals screen with them, your formula. If there's a discrepancy between your 2 answers. How much is it worth in 3 years? Here we go. So, we've got this thing entered in the calculator, then we go to the table and we look at 3 years later. And if I go to, I'm going to go to my table settings and have it start at 0. And then, would it make sense for me to look at U sub 3? No, because that's 3 what? 3 months. I'm obviously trying to pound that in because that's the common mistake. Okay. Is our amount going up? Yeah, and it actually makes sense in this case because it's an investment. We want our money to grow. All right, so after 3 years would be 3 times 12, which would be 36. I'm just going to go a different way. Do you remember how to do this one? U sub whatever. I'm curious, how many of you did U sub 36 to get this answer? It's not like you're a better human, but it's faster. All right, thank you. So 4 people remembered that. It's a lot faster than going to your chart. Yes, sir?
So what if it was an investment problem, but they wanted to keep $10 out of it?
That would be something that's beyond what we would do with this kind of a calculator. I mean, obviously you could do it in the real world. And there are people that they're trying to live on money that they have in the bank. Let's say they're old and they've saved up a bunch of money. So their money grows, but they want to take some out every month. That is a scenario, but we aren't going to do it. It's complicated. All right, final answer. Aunt Tilly's money is now grown to $13,107. Now, if you just think about that for a minute, that's $3,000 more than you had in the first place. Just for perspective, if you want to work all summer as a high school kid, that would be like what you'd make all summer if you worked really hard. Maybe $3,000, maybe. And it really depends on the job. There's people who make less than that. There's some people who make a little more than that. There's some jobs that are based on sales. There's these crazy jobs where you actually walk door to door and try to sell like knives and things like that, Cutco and whatever. And they actually, if you're a top salesman, the top, and you have to be really good and really pushy and really whatever, you might make $10,000 in the summer. Okay, that's really unusual. A normal job, you can just do the math on it. You're gonna probably, if you go to Jimmy John's, you get paid like $9 an hour, and that's if you're lucky, because they can pay you as little as $7.50. So let's say you're making $9 an hour at Jimmy John's, times how many hours in a week? 49 times 4 is about $350 a week or so. Plus, they're going to take taxes out of that. And then if you're going to take any time off over the summer, you're probably going to make less than $3,000. So, okay. So, bottom line is, if you can make your money work instead of you having to work, it's always a good thing. All right. So that's it. That's what you have to know for today. And I guess we can do a few of these kind of questions where it's just like, what is the thing? Is this one, just by looking at it, is it a loan or is it an investment? Investment. And what one symbol told you that? The plus. That's right in front of the 25. Yep. That told you it's an investment. Okay, if it's an investment, what's the principal? 150. The deposit amount, principal always at the beginning there. Deposit amount or payment amount, just say it if you know it. 25. Annual interest rate. Some people get confused by this and think this whole thing is the annual interest rate. No, the annual one is the one we started with, the one on the top. This one's not paying a lot, 2% annual interest. But in the real world, it's actually high for a checking account or a savings account nowadays. They don't even pay 2%, way lower. Frequency. This one's this one's not monthly, it's quarterly, right there. If you had said 4 times per year, I'd been fine with that. All right. So, housing prices. These are some of the most expensive places, and in fact, this is an old list. One of the most expensive places is in Minnesota. There are some really expensive suburbs around here. Obviously, if you could narrow it down to just like lakefront property, Lake Minnetonka would be one of the most expensive areas. But you just count the whole city of Minnetonka, you got a lot of normal houses, and you throw in the big ones. It raises the average, but it's not near as big as it would be if it was just on the lake. Pacific Palisades, it's right near LA. It's really expensive to live out there. And if I'm going to go visit near there, I noticed like the rents, holy crap. You want to rent a place there for a week? It's about $900 a day to rent a place in the Palisades. Yes?
One of the questions in the notes that asks us to like find the amount we have to pay per month to get it exactly 60 months.
That is a good question, and I'd like to show you another app for that tomorrow. But in the meantime, what you're going to have to do to figure out how much do I need to pay, you start with an amount and you guess and you check. It's a guess and check problem. Now, I don't need you to, like, what he's talking about is, let's do one of these where I'm going to see if it's on this last problem. Let's pull a bunch of it. How long will it take? What's your balance? Yeah, this is not even covered in our notes for today. So the self-exploration one on the worksheet means that it's obviously you're exploring it. We're not supposed to tell you, how exactly to get the number. Well, I will tell you exactly tomorrow, but today it's just guess and check. You try a payment, you see did it get paid off in time, and if it wasn't, big enough payment, you try another payment. You stick it in the calc. It doesn't take long. Change it on the calculator. See if it paid off in time. And they want you to pay it off by a certain time. And it makes sense because in the real world, you can't just stretch your payments out forever. So basically, you just keep tweaking your formula that looks the same as all your other formulas. Here's your original loan. 1 plus, and this is pretty much always going to be monthly. We'll change it every now and then just to shake it up, but in the real world, it's pretty much always monthly. Let's say it was 9% interest, and the payment you were going to make on your $10,000, you're not sure how much to make. Again, what if we didn't tell you? And that's the extension problem. You just try something. You know, from my experience, just pick a nice round number, like $200 payments or whatever, and then see if it worked. Look on your table, see was it paid off. Oh, I paid it off too fast. So you don't make as big a payment. Or if I paid it off too slow, I make a bigger payment. You just keep playing with that number until you get it right. But tomorrow I get to show you the real way to do that, and it's pretty cool. But it's complicated and it would take up all the rest of our time. All right, so let's do the homework for today. Let's start it together. So if you could all find the worksheet, which I think you'll know where it is, right in here. Loans and investments. Make sure I'm not opening the key by accident. I'm going to do it this way. All right. So let me just take a look at it here and make sure it's not ungodly long. It's not. That's not bad. A lot of these are just what is the amounts, and those will go really fast. And then here's write a recursive formula. We just practiced that. It tells you how much to pay per month. Notice it says months, and therefore you'll need to divide by 12 in your formula. Yeah, this will be an easy worksheet. I don't want to remove any of them from your assignment for today. Since I was gone yesterday, I'm not going to put the homework in. Wait a minute. You guys, all you had was the review for the test, so I want to figure out a way to put those in, but not going to do it today. In the last few minutes, I have to give you your tests back, and I'm going to pause. Actually, I guess that's all I need for the video for today, so we're done.